Hello students, I welcome you all for my channel Simply Tricks. In this tricks, now we have started the series called as C by examples, in which we are going to learn the C concepts based on the examples. We are going to see few examples, few programs based on each and every concept. So today's our topic is first topic, that is C expressions based on arithmetic operators. So we are going to see few programs based only on arithmetic operators. Now, in C programming, there are five arithmetic operators, basic operators. These are five basic operators. What are that operators? Plus, minus, star, slash, and mod operator. How this operator works? The first operator is called as the addition operator or plus operator. So let's say we have two numbers A and B. So their addition is performed as C equal to A plus B. Similarly, there is subtraction is performed as A minus B, which we are going to store in a variable called as C. Similarly, we are going to store the multiplication of these two numbers in variable called as C. The division of two numbers we are going to store in C using A slash B or A div. And the next operator, which is new in programming, which is not there in mathematics, called as a mod operator, which is denoted by percent symbol. So what this operator does, it basically divides A by B. In C, where there are two types of division. One is integer division and one is called as remainder. This is not the just division, it is a remainder. So what happens whenever we divide a number? Let's say we are dividing a number 10 using 2. So 10 div 2 will give you the answer as division, that is 5. Whereas 10 mod 2 will give you the remainder after dividing by 2 to the 10. So we will get this number as 0. Okay, so that is called as remainder operator or mod operator. So based on these operators, we are going to see few programs in this first type of programming. That is addition, subtraction, multiplication, division, and of course remainder of two integers, float numbers, short integers, long integers, and double integers. Second program we will see square, cube, reciprocal of a number. Then third program we will see decimal to octal and hexadecimal number. Then area and perimeter of 2D shapes, in which we are going to see how to calculate area and perimeter of circle, triangle, square, rectangle, and oval. Then we will see surface area and volume of cylinder, cube, cone, sphere, and pyramid, that is 3D shapes. Then we will see how to calculate the simple interest using C program based on the arithmetic operators. Then we are going to see percentage calculation based on the marks of few subjects. Then how to convert a temperature from one unit to other. So in which we are going to see Celsius to Kelvin conversion. Then we are going to see how to swap two numbers or interchange two numbers. Then we will see arithmetic, geometric, and harmonic mean of two numbers. So these are the 10 programs which will be the agenda of this particular video. Okay, let's see the first program now. Simply tricks. In this channel, we are going to start. We have started with the new series called as C by examples, in which we are going to see few examples only based on the concepts of C programming. So first category, first program we are going to see in this case, that is addition, subtraction, multiplication, division, and remainder of two types of numbers. Two types of numbers, that is integers and float numbers. In integer there are three types again, and in float there are again two types. So basically there are five types of numbers on which we are going to perform arithmetic operations. So let's see how to do this program. First of all, think about what should be the output, what will be the expected output. So the line of this output will be, first line of this output will be enter two whole numbers. First category, that is integers, where we are going to enter two whole numbers. Okay, and these whole numbers can be small sized, medium sized, or large size. So first we will see medium sized, which is generally a programmer is using, that is integer data type. So the first line should be enter two whole numbers, and then we are going to enter two numbers. Addition of these two numbers will be the final output. This is what the required output. Now in this case of programming arithmetic operators expressions, the flow of the program is like this: input, process, and output. Where first we have to think about the output. That is, just now we have seen the output should be like this. And based on this output, determine the input. So what will be the input? That is input in this case will be two numbers, 100, 200, whatever it is. So there will be two variables required, input variables. So we can determine how many variables are required, what type of variables are required. So 100, 300, these are quite small numbers. So we can declare this as a short integer, 10,000, 50,000. If these are the numbers, then we can declare them as a the normal integer, 1 lakh plus 2 lakh. These numbers are there, then we can declare them as a long integer. So based on this output, we can predict what will be the input and use that input for in order to start the program. Now to convert this input into the output, we need to write the formula. We need to convert this is in the using process, and that process we are going to write using the formula. So for arithmetic operators, for first case of these programs, there are already formulas available. If the formula is not known to you, you can just Google them and find out the formula, learn that formula, convert that mathematical formula into C expression formula, and just write the program. Now we will see how to write this first program for addition of two integers. Now in this case we have taken two numbers 100, 300, that is simple integers or small type of integers. So for them we can declare this as a short integer. Okay, so let's start with this first program. The first line of the C program, that is the standard C line, as you know, hash include std which we include for printf and scanf functions. Then the second function, second line is the entry point function, that is int main or void main. After that we declare the next line as opening curly brace and the last line as closing curly brace. Opening curly brace and closing curly brace are the begin and end of the programs. Then the next line we start with the variable declaration. So as we saw, there will be three input variables required, three variables required. Two will be input variable, one will be output variable. So declare all that variables. Short int, because now we have given the input as 100, 300. So based on this, we have determined that there will be short int, okay, and A, B, C. These three variables will be required. Now the first line is enter the two whole numbers. So in printf, in double quotes, we have to write enter two whole numbers. And this line will be ended by the semicolon. Every C program line ends by the semicolon. See the syntax of printf, basic syntax. Printf, all in small cases. Then left bracket, double quotes, slash n can be there to format the output. Then whatever line you want to print on the screen. Enter two numbers, enter two whole numbers, enter first number and second number. So that line you have to write in double quotes. Double quotes completed, right bracket completed, and semicolon. Yes, that will be the first line. Then how to accept these numbers? Using scanf. In scanf we have to write the format how we are going to accept two numbers. Now this is short integer. So for short integer, what we can write is percent hi, percent hi. So these are the two formats we have to write because we are accepting two numbers. Percent hi, H stands for short, I stands for integer. So percent hi and percent hi. So this is the first change or first part. Second part, that is percent hi. And then accept these two numbers in A and B using ampersand A, comma ampersand B, followed by right bracket and then semicolon. The next is, as I told you, after accepting the input, you have to write the process of it. And in this first case, the logic is very simple. The process is nothing but in terms of the formula. So the formula for addition of two numbers is very simple. C is equal to, that is resultant variable equal to first variable plus second variable. C equal to A plus B followed by semicolon. And just display this output. Addition of, now the output is addition of 100 and 200, 100 and 300. So this 100 and 300 again are short integers. So we have to write percent hi for them. Percent hi is equal to percent hi. So this is the correct way to write it. So printf addition of percent hi and percent hi is equal to percent hi. Double quotes completed, comma A, comma B, comma C. So that this first A, value of first A will be replaced in percent hi, value of B will be replaced in second hi, value of C will be replaced in third hi. That is the entire program. And end this program using the parenthesis, closing parenthesis. Now, whenever we execute this program, the first line is nothing but short int. Okay, so this short int create short int ABC, create three variables at different memory locations. In memory, there will be different locations. So first variable is A, second variable is B, and third variable is C. So in memory, at some locations, let's say at 1K location, at 500, at 23 location, at some location, these numbers will be declared. These variables will be declared. So there will be memory assigned for them. And whenever we declare these variables, random value is assigned to this. It gets stored automatically 5, let's say 50 to 34, which is of no use for the programmer because programmer have not stored this value. Program automatically saves this value, creates this value whenever we execute this program, and that's why we need to accept it from the user. As and when we accept it from the user, this the wrong values which is for user, gets automatically deleted, and instead of them, the user entered values will be entered. For example, here if I am entering 100 will be stored here. I am entering second number as 200 will be stored here. If I am if I am storing the addition 400, that 400 will be stored here. And that's the reason we need to accept it from the user, so that the output will be based on the user input as well as accurate output, because initially it was not containing the addition of first two numbers in the C location, and that's why we need to follow this sequence. That is the first part of this program. Now the second part, this is the first part, short integer. Now the second part of this program, students, we have to convert this program into the middle range values. Okay, so this is what we have seen just now. Now for conversion of this, just make three changes. First of all, try to understand what the integer means. Now these these numbers are of small range. Now we have to convert this into the middle range. Let's say that middle range is up to 10,000 or 20,000, something like this, or maybe say up to 50,000. So I am giving the numbers as 50,000 and 20,000. So definitely these numbers should be calculated accurately, and their output should be done accurately. So to give these numbers, and we have to get the output, accurate output, 50,000 and 20,000. The output will be 70,000. So here we expect the output as 70,000. So to make these changes, to correct this program, we just have to make 2 to 3 changes. First of all, while giving the input, we have to give the numbers like this. Second, instead of writing short int, we have to write int. This is the second change. And third change is nothing but what? In the format specification, we just have to write %d. D is for decimal, D is for middle range integer. And here also we have to write this value as %d and %d. That's it. So once we make these three changes, the program automatically will be updated for the middle range values, middle range integer values. And you can give the input as 50,000, 20,000. Not only 50,000, 20,000, but you can give the input in terms of 100, 200 also. So integer will cover both short integer as well as middle range integer. And that is what this integer is. You can give negative numbers also. So this is the second category, that is integer. Now the third category is nothing but long integer. So now suppose you want to give the numbers in terms of millions, billions or trillions. So first thing you have to give, and more than that also you can give, but then that may not be fit within the range if the compiler is not supporting that much ranges. So you first have to check what is the range of your compiler, and accordingly you can give the number. But let's say 1 billion, 2 billion, 3 billion, these compilers these values can be supported by a editor or IDE. Then how to process these numbers using the arithmetic operators. So let's say I'm giving that number as, now instead of 50,000, I'm making that number as 5 million and 2 million. So the output I'm expecting as 5 million, 2 million plus 7 million. So the again change is very simple. Instead of int, you can make this as either long int or just long. Okay, both are valid and both will give you the correct result. Second change we have to write, that is %ld or just %l. %l. Either you can write percent LD or percent L, percent L. That's it. So here also you have to make the changes percent LD, and percent LD. That's it. So this is the second change you have to do, and you can do the program based on the large numbers. And once you have declared this as a long integer, you can of course give middle range integer as well as short range integers also. So 100 to 100 will also be added correctly. Then 1,50,000, 20,000 will also be added correctly, and all the operations will be done perfectly on them. So this is what the third variation, that is the long integer. So this third variation, that is long integer. So these three types of numbers are basically whole numbers. We can say without fraction or without point. Now the next category of number is nothing but fractional numbers, where we are going to give the points. Again, there will be two types, like middle range values and high range values. There is no small range values here in this case, because float itself is made up of two types of integers. One integer for decimal place and integer for fractional place. So basically, small float numbers are also made up of 4 bytes. Long float numbers are also made up of 8 bytes. So long float numbers are itself called as double. So there will be two categories in fractional numbers, float and double. Float and double. Now we'll see how to make the changes in the same program for fractional numbers. So first thing, you have to write this, enter two whole numbers. Instead of this, you have to write this as a fractional numbers. Fractional numbers. And to change this, what we can do, instead of writing here whole, we have to write this as a fractional numbers. This is the first change, so that this printf line will change the line on the screen, first line on the screen. Now the thing is, we have to give the number in terms of a fractional number, positive or negative both. So here, instead of this first number, you can give the number as 1.1, and here let's say 2.2. Okay, so this has to produce the output called as 1.1, 2.2. Addition of these two is 3.3. Right? So how to produce this? So again, last time we have seen, just change the data type and format specification. So instead of this long int and long, what we have to do, instead of integer, we have to just make one change, that is float. So we can just write this value as a float. This is the first change. Second change, we have to write this as a, instead of %d, %ld, we have to write this as a %f. F stands for float number. So here I am writing f, here I am writing f. Here I am writing f, here I am writing f, here I am writing f. Right? Only the thing is, practically it is working slightly different, but that we'll see in terms of execution. Let's get clear with the theoretical aspects of this, and in practically the output will be slightly different, but that we'll discuss while execution. So this is the first change we have to do, or second change we have to do. Change the data name of the data type and format specification. That's it. The program will be ready for float numbers and fractional numbers with a medium range values. Right? Now the last part, students, is for long float, or we can say double numbers. Long float means the double or twice the float value, twice the float range is called as a double values. So in that case, we can make some changes. So first of all, these numbers will be given as, let's see what that numbers will be. So the numbers can be given as 50,000, or let's say 50 million, 0.23, 2 million, 0.12. Okay. And output, we expect that as 7 million. Okay, so again, the changes are very simple. We just have to change, this is the extended part of float, so we just have to change this float to double. That's it. And the format specification, now format specification is Very simple. Double is nothing but twice the float. Twice the float. And for twice in C we write long. Like integer, we have to make integer twice. So we were writing LD, long decimal. So here we have to write LF. That's it. Once we make this as a LF, the program is ready for your long float, that is double, and you will get the desired output, that is addition of two long floats or double numbers. That's it, the output will be produced correctly. Only the thing, the output is not produced exactly as we can see in the board, but yes, definitely we'll discuss this in the execution, and then you will come to know how the output is slightly different and how to bring the correct output. So that's all for now. Let's see the practical part of this particular program. Hello students, now we'll see the practical implementation of all these 5 programs which we have seen in the theory part. So let's start with the Dev C++. I'm using Dev C++ compiler on Windows platform. So this is the starting screen of this Dev C++, where we can see file, edit, search, view, project, execute, the tools, a style and window menu, out of which will require very few in the initial days of the programming. So let's start with the new program, that is the first program. Click on the file and then click on the new option and then click on source file. Okay, so here I'm starting with the new program. Okay, so let's start with the first program, that is addition, subtraction, all 5 operations on integers. This is the first line, which is the standard line of every C program. Then entry point function, then opening curly brace, closing brace plays the role of begin and end. Then we declare the variables. We require minimum 3 variables here, that is input 2 variables and one is output variables. Then in print first line, that is we are going to print enter 2 numbers. This line will be printed on the screen as it is. Then we are going to accept 2 numbers using scanf. Of course, this first program we are going to accept simple numbers without fractional numbers and medium range numbers. So we are accepting 2 numbers using 2%d. Let's say we are accepting ampersand a and ampersand b. So the addition we are going to store in C using the formula a plus b. Immediately declare the result. Percent d plus percent is equal to percent d, so that the output will be printed as value of a plus value of b and equal to result, that is C. Now calculate the subtraction using the same formula. Instead of plus, we'll use minus symbol. So let's copy these 2 lines for the next formula. This is for minus, multiplication, subtraction, so division and remainder. So let's do this. Minus, then minus, that is subtraction. Then we'll compute multiplication. Then we'll compute division. And then we'll compute remainder. Let's check this program now. Now to compile this program, we have 3 options. What are that 3 options? Let's see this. Just say these 3 operations. In execute, in the menu bar you will see one option called menu option called as execute, under which you will see 3 options. One is compile, that means just to check the errors whether the program has written correctly or not, and it will produce the object code. Second option is once the program is compiled, you can execute this, or pre-compiled program you can execute directly using run. Okay, and sometimes you need to compile it, and if it is correct, like if you are sure that the program will be compiled surely and it will run, then you can click on the compile and run. Then the last option is rebuild all, like when we have multiple programs and we want to compile it in one and make a simple file, make a one executable file, then we need this rebuild option. So generally this option is required whenever we do the project in C programming. So let's start with the first option, that is compile. I'm clicking on the compile. Now what option it is showing, that you have to save the program. So let's save the program. Say calc int dot c. Okay, I'm saving this program as calc means calculator, and save. So I'm saving this program now. Now see this output. Again I will show you the output.
you can see the output as errors equal to 0, warnings equal to 0. Okay, and the output file name is calcin.exe. So you can double click on calcin.exe from the my computer option also, and you can execute the program, or else you can run the program by clicking on run option from the execute menu. Okay, and it is also showing the compilation time. So as the errors are equal to 0, warnings are equal to 0, now we'll find the result using run option. Okay. Execute, I'm clicking on execute and run. Now you can see the output. Enter two numbers. Now we have compiled this program, or we have written this program for integer. Integer, that means medium range. So on Dev C++ or Linux platform, GCC compiler, basically the integer size is 4 bytes. So we'll give the numbers in uh, the format 50,000 to 1 lakh, so that it will be medium range numbers. So let's say I'm giving the number, first is 50,000 and second is say 90,000, and we can see the output as C. 550,000 plus 90,000 is equal to 1,40,000. The output is correct, only the thing is not formatted. So we'll correct this output now. So I'm just writing /n in each printf, so that it is showing the correct output. This is just for adding the formatting. Now let's compile this program and run. Now I'm clicking the third option, that is compile and run. Okay, so 50,000 I'm giving the first number, 90,000 same number I'm giving, and now you can see the output, which is in for correct way. Only the last line %d, it is showing the wrong formatting. So this is because we have written just 1% symbol. So basically this symbol we have written to print 1% on the screen, but it is again in C programming we cannot we cannot print percent symbol using just one print percent symbol. We have to give 2% symbol, so that it will print 1% symbol on the screen. Now let's compile and run again. I'm giving the number as 50,000, then 70,000, and now you can see the correct output. Absolutely the program is working fine with all the corrections. Now this is the correct program, rather accurate program. Now we'll make the second change. Okay, instead of int we'll make this as a short int. So we have to make another changes also for short int. Short int is required when we have the numbers in small range format. Now small short int on Linux is nothing but 2 byte format. So 2 byte, that means 2 raised to 32, that means 65,000 or below range we can enter the numbers. Now to run such kind of programs, run such program, we need to make two changes. One is nothing but you can change the data type from int to short int, and then second change, wherever there is a %d, you have to make this as a hi, or simply hi. Everywhere I have to make hi. H stands for short and I stands for integer, so hi. So everywhere you have to make hi, so that the output will be correct one. Hi. That's it, guys, and we'll run this program now for small numbers as well as for large numbers, and we'll check how this is not giving you the correct answer for large numbers, because the range is little bit slower here. Hi. Right, so that's it. Now we'll compile and run this again. Now again I'm giving the same output, 50,000, which is more than 2 bytes, 32,000. So let's see the output. Now see, these numbers are different. The numbers, it is not showing you the error, but it has changed the number. So again for this number, there is a specific reason why this 50,000 is converted into the another number. This is because 50,000 is beyond range of the short range, short int. So now we have to give the proper numbers in order to execute in using the short int. Second thing, if you want to run for the large numbers, of course we have to make the changes, and that means we have to convert this short into just normal int. Now we'll correct this, we'll execute this program again, and now we'll give the small numbers, let's say 500 and say 4,000, something like this. See, now you can see the correct output. So this is what the second data type, that is shortened. That means when we have the small set of numbers, rather small range of numbers. Now the next is opposite of this is long int. So for long int we have to make this one change as long int, change the int to long int, and second is LD. We have to make the format character as LD. So everywhere wherever this is a HI or D, we have to make this as a LD, so that we can give the long range numbers. For example, let's say I want to add, or I want to do the computation based on 1 million 1 billion numbers. So for that this specification is required, LD. So LD, everywhere I am making this as a LD, so that correct output will be produced. Yes, all the changes are being done now, and you can see the output for 1 billion, which was not possible using the integer. So LD, LD, yes, LD, yes, here also we have to make this LD everywhere wherever this long integer is used. So everywhere I have made these changes, two types of changes. Now compile and run again. So now definitely for long integer, if I give the numbers as 500 and 1000, definitely it will give the correct answer, because it is in the range of long range integer. See, it is giving the correct output. Now second input, like which we have given in terms of integer, say 50,000 and now 90,000. So it is giving me the accurate output. And third case, like when we have the numbers in terms of 1 billion. So 1, let's say I'm giving 1 followed by 7 zeros. Now see the output, 1 million billion plus was 5 billion is equal to 6 billion, and all the answers are correct, absolutely correct. And this is working fine for the long integer also. Now this is what these are the three data types which we have seen for non-fractional numbers. Now for fractional numbers, we have to uh, make two changes again, two ways, right? Rather, one is float. Float means again it is in the normal range, and say another is the double. Double is nothing but twice of float. So float is generally requiring 8 bytes, okay, in on GCC platform. So again for float you have to make two changes. One is nothing but here you have to make either F or E, both are valid. Let us see first F. F. So everywhere wherever there is a D, you have to make this as a F. Now let's see the result of these 5 operations. Definitely it will create some problem for one operation, but let's check. Again compile and run. Now see, it is not getting compiled only because C equal to A mod B is not able to perform on float numbers. Yes, directly it is not able to perform on float numbers, but we can compute. But let's make this as in a comment line, and first of all check the result of these 4 operations. So now we have to give the numbers as in fractional format. So I'm giving two numbers in fractional format. Now you can see the result, right? So this is the result. Now what we can see is 578.56. Okay, 578.56, but now it is showing you the result in different way. So this is the change which we have done, which is done by C programming. Default change that every fractional number is always represented using 6 decimal places. So we have given the number is 56, which is converted into 5599998, which is actually approximately equal to 56 only, 0.56 only. But yes, this change is done. Now we can change this format like 578.56, so we can convert this into 2 decimal format. But for that we have to make some slight changes in the printf statements, so that we will learn in float, sorry, not float, that we will run in printf functions. So we will see one more video in which we'll in detail we will see printf function for float numbers, for integer numbers, for all types of numbers rather. So there you will understand how this number can be changed to two decimal places. Now just remember that every fractional number or float number is represented using the 6 decimal places. So that's it. Now we have to make one change. So we obtained 4 results. Now the last result, that is the fractional numbers remainder, that is not possible directly using a mod b. So for that, what we have to do, we have to use one function, one built-in function called as f mod, and then we just have to give these two parameters a comma b, because we want to compute a mod b, and then we can add this in the c. Okay, but this program is this function is included in math.h, so we have to include that file, and then let's check the result. Compile and run. Okay, now 5.8. I'm giving again two fractional numbers. Now see, this result is, so we can see the last result, that is now it is able to compute the mod also. Okay, so that's the way to do the program for fractional numbers. Now the next category for fractional number is nothing but double. So I'm writing, instead of float I'm writing double, and here we have to just write LF, because L stands for long and LF stands for long float, that means twice of double. So everywhere we have to make as LF. That's it. This is the second change, and we can write the program for now 1 billion point something. So that is the fractional number, quite big number, but using the fraction. So yes, everywhere we made the changes now, and now compile and run. Okay, so 1 billion, 1 followed by, let's say, 7 zeros again, point something 5. Now see the result. Now we are getting the accurate results for this also. So these are quite large numbers and fractional numbers, so we can execute this for quite large numbers, that is using double. That's it, guys. So this is all this today we understood 5 data types practically in the first type of program, that is addition, subtraction, multiplication, division and remainder. So let's add this into the comment. So in comment you can write, every C program must contain the comment, so that you will remember for which this program is written. So I'm just writing that in the comment. So the title of this program is addition, subtraction, multiplication, division and remainder of two fractional and non-fractional numbers. So two fractional, that is float and double, non-fractional, that is integer, short integer and long numbers. So that's it. This was our first program. Now just wait and watch my second program explanation in the next upcoming video. Thank you.
5